Welcome to the Deep Dive, the show where we try to cut through all the noise and really pull out the insights that matter.
Glad to be here.
Today, we're diving into a topic I think is just absolutely fundamental, especially now. It's learning how to learn.
Yeah, think about it. What if you could get really good, maybe even like world class at almost any skill?
Right.
Not in years, but maybe just a few months.
Mm.
Or on the tech side, imagine building a machine that learns totally new stuff with just like a handful of examples, not millions.
It's the dream, isn't it?
That's the power of meta learning.
Exactly. And in a world just overflowing with information, the real edge isn't just knowing stuff. It's how fast and how well you can learn the next thing. So our mission today is to really take a deep dive here. We're looking at, solid academic research, practical frameworks people use for learning fast, and even how AI is tackling this.
We want to pull out the key stuff, like how do we learn best? Which strategies really work?
And crucially, how can you, listening right now, use these ideas? How can you become a better, more efficient learner without getting totally overwhelmed?
Okay, let's start mapping this out.
So, where do we begin? What's the foundation?
Well, the foundation in the research, it's really this concept called self-regulated learning, SRL for short.
SRL.
And this isn't about just, sitting back and absorbing things. It's active, it's constructive. It means you, the learner, you set goals.
You're in the driver's seat.
Exactly. You consciously monitor, you regulate, you control your own thinking, your motivation, even your behavior, all guided by your goals and the environment you're in.
So it really sounds like taking ownership, not just waiting to be taught. What are the key bits for that?
Well, it involves that active part, like you said, having clear goals, knowing where you're headed, using learning methods strategically, being aware of your environment.
And staying motivated, I guess. That's always a tough one.
Definitely. Sustained motivation is huge. And a critical piece here is metacognition. Think of it as the control panel.
Metacognition. Thinking about thinking.
Pretty much. It's your knowledge about how you think and learn. And you need that to use learning strategies effectively on your own. But here's the really cool part.
Yeah.
It's not fixed. Metacognition can be trained. You can actually get better at it.
That's huge. So we're not just stuck with how we naturally learn. We can improve the engine itself.
Precisely. And that makes sense why SRL is, well, more important than ever.
How so?
Think about the shift in, education and work. The OECD, that's the Organization for Economic Cooperation and Development, that keeps saying lifelong learning isn't optional anymore. It's necessary.
Right. Things change so fast.
So education is moving away from just memorizing facts towards self-directed learning.
Yeah.
But the catch is many students, especially younger ones, they often lack these SRL skills.
Like what kind of skills?
Things like summarizing well, or knowing if they're actually understanding something, or, staying motivated without a teacher pushing them. They don't always pick these up automatically.
So just trying harder isn't the answer. We need a strategy for learning itself.
Exactly. And the research breaks these strategies down into helpful categories, gives us a kind of roadmap.
Okay, what's the first category?
First up are cognitive strategies. These are more hands-on, task-specific methods.
Like the actual doing.
Sort of, like elaboration. That's actively connecting new info to stuff you already know, building mental bridges.
Okay.
Then there's rehearsal.
Yeah.
Just repeating stuff, maybe saying it aloud or in your head to lodge it in memory.
Classic memorization technique.
Right. And organization. That means structuring things, maybe categorizing information or turning a block of text into a mind map or a chart, visualizing it.
Got it. So those are about handling the information itself. What's next?
Next are the metacognitive strategies. These sound a bit like what we talked about earlier, managing your own thinking.
Right, the control panel stuff.
Exactly. These are higher level, used across different learning phases, like planning and prediction. That's thinking ahead. How much time do I need? What's my plan? What resources will I need?
So prepping for the learning session.
Yeah. Then there's monitoring and control. This is checking in with yourself during learning. Am I getting this? Maybe asking yourself questions. And if not, you adjust your approach.
Okay, like course correction.
And finally, evaluation and reflection. This happens after the task. Reviewing how it went, checking answers, seeing if you met your goals, learning from the process.
It really is like being your own coach. Looking at the game tape afterwards.
That's a great analogy. And beyond processing the info and managing your thoughts, there's managing the practical side.
Like where you study and stuff.
Yeah, those are management strategies.
Yeah.
Optimizing your environment and effort. So effort management is basically persistence. pushing through when it gets hard or boring, tuning out distractions.
Building that grit.
Exactly. Then environment management. Finding the best place to study, maybe quiet, maybe not. Using resources effectively, like a dictionary or searching online.
And what about other people? Does that fit in?
Yeah, it does. That's management of others. Knowing when to ask for help, or maybe working with others, collaborating, if that helps you learn.
Okay, that makes sense. Sometimes just finding a quiet spot is half the battle for me. Or just getting started.
Right, and that leads to the last category, motivational strategies. Boosting your own drive.
Ah, the internal engine.
Yep, includes goal orientation, setting clear goals. Are you aiming just to pass the test or really master the subject? That focus matters.
Performance versus mastery goals.
Right. Then task value. Believing the task is actually important or relevant to you makes you care more.
Finding the why.
And self-efficacy. That's your belief in your own ability to succeed at the task. It's a really powerful predictor of whether you'll stick with it.
Okay, so we have all these different strategies: cognitive, metacognitive, management, motivation. That's a lot. But what does the big picture research say? Like you mentioned meta-analyses.
Ah, yes. The meta-analysis on teaching these strategies is pretty compelling.
Does it actually work? Does teaching this stuff make students better learners?
Emphatically, yes. The overall impact is significant. It shows a medium to high average effect size on student performance. The stat they use is Hedges G, and it was 0.66.
Which means, for someone not up on stats.
It means it has a very real, substantial positive effect. This isn't just some nice idea. Teaching these strategies measurably boosts how well students do.
Wow, okay. That's strong. But does it work equally well for everything? Like, is it better for math than for history or?
That's where it gets really interesting. The impact does vary by subject.
Okay.
For reading comprehension, the effect was smaller, more moderate, still positive, but smaller. Hedges G was 0.36.
All right.
For mathematics, it was medium to high, similar to the overall average, 0.66.
Okay, good for math.
Science also saw a medium to high effect, even slightly better at 0.73.
Strong results there, too.
But the real standout, the one that just jumped off the page, writing.
Writing, how high?
A very high average effect size.
It hit
is G of 1.25.
Whoa, 1.25. That's massive.
Yeah.
Why writing? Does the research suggest anything? I mean, it feels like writing is a very metacognitive task.
Yeah.
Planning, drafting, revising.
That's exactly the thinking. The meta-analysis itself focuses more on the results, but researchers speculate it's because writing inherently demands that kind of self-regulation.
Right.
You have to plan, monitor if you're being clear, evaluate your own argument, reflect on feedback. It's SRL in action, almost by definition.
So teaching the strategies explicitly just supercharges a process that's already kind of built for it.
It seems likely it's fertile ground for these skills to really take root and show big gains.
Fascinating. Okay, so digging deeper into the strategies themselves, did the analysis find that certain ones are like star players? Or maybe combinations?
Yes, definitely. Overall, the most effective combinations seem to involve teaching general metacognitive knowledge.
Yeah.
That's the knowing how, when, and why to use strategies.
Kind of the instruction manual for the strategies?
Exactly. Combine that with focusing on planning and prediction and boosting task value, helping learners see the point. That mix tended to work best across the board.
Okay. What about for specific subjects, like that super effective writing result?
For writing, the winning combo was that general metacognitive knowledge plus the metacognitive strategy of evaluation and reflection.
So knowing how to use strategies and specifically using the ones about checking your work in process.
Right. And that specific combination pushed the added value even higher to a Hedges G of 1.32, just for adding those elements.
Incredible. What about math?
In math, the cognitive strategy elaboration, actively connecting new stuff to what you already know, showed a clear positive effect, helping students build those connections.
Makes sense for math, building block on block. But reading comprehension, you said the overall effect was smaller. Did elaboration help there?
And here's where it gets really counterintuitive and, frankly, super interesting.
Go.
For reading comprehension, elaboration actually had a negative effect.
Negative, like it made things worse.
According to this analysis, yes. And so did the management strategy pierce others. So, seeking help or collaborating.
Wait, collaborating hurt reading comprehension. That seems backwards. Why?
It really challenges simple assumptions, doesn't it? The speculation is, for reading, maybe too much elaboration distracts from just understanding the main point. Gets you lost in the weeds.
Okay, I could maybe see that.
And for relying on peers, perhaps in reading tasks, it stops you from doing the hard work of grappling with the text yourself. You rely on others instead of building your own understanding.
Huh. So context is everything. What works wonders in one area might actually be detrimental in another.
Precisely. It's not a one-size-fits-all toolkit.
Yeah.
Oh, and for science. Interestingly, while SRO overall helped a lot, no single strategy stood out as significantly more effective than others.
Okay. So besides the strategies themselves, what else mattered? Did it make a difference who taught these skills or how long the training lasted?
Yes. A couple of other surprising things popped out. Interventions run by the researchers themselves or by other trained assistants tended to get bigger results than when regular teachers or computers delivered the training.
Why would that be?
Could be a few things. Maybe a novelty effect, students respond to something new. Or maybe, and this is a bit cynical, researchers are just better at, teaching to the test used in the study, focusing tightly on the measured outcome.
Interesting. What about duration? Longer must be better.
Yep, you'd think so, but no. Counterintuitively, longer interventions actually had slightly lower effects than shorter ones.
Lower.
Yeah, the effect was small, but still, it goes against common sense.
Yeah.
Maybe shorter, more focused bursts are better, or maybe longer programs lose intensity. It's hard to say for sure from this data alone.
Wild. But maybe the most important question. Do these skills stick? Or does the benefit fade away after the program ends?
This is maybe the most exciting part. The benefits don't fade. Yet the positive effects on student performance actually sustained over time. In fact, they were often slightly higher in follow-up tests after the programs ended compared to right at the end.
Wow. So learning these skills provides lasting value. They become part of how you operate.
Exactly. It really speaks to the long-term payoff of investing in learning how to learn. These aren't just temporary boosts, they're foundational upgrades.
Okay, so the science is solid. Teaching self-regulation, teaching metacognition, it demonstrably works and has lasting effects. But how do we take this out of the lab, out of the classroom, and make it practical for, anyone listening who wants to learn something new?
Right. This brings us to the practical art of meta-learning. Thinking of it not just as a school subject, but as a meta-skill.
The skill that helps you build other skills.
Precisely. It's shifting from just focusing on what to learn to understanding how to learn anything faster and better. It's like having a map-making kit for any subject you want to explore.
A map. I like that. So how do you make this map?
Well, you need two kinds of knowledge, right? There's knowledge of the Spanish words, the code, the cooking techniques.
Domain knowledge.
Right. But then there's the meta-knowledge. How is this domain structured? How do the pieces fit together? What's the best path through it? That's the map. Meta-learning is about building that map.
And author Scott H. Young, who's famous for learning complex things super fast, he has some core questions for building this map. Right.
He does. 3 key questions. First one, how do other people draw the map? Meaning, don't start blind. Look at existing maps. Check out university curricula, popular textbooks, online courses, how experts structure their teaching. Even just Googling how to learn X can show you common structures.
Leverage the work others have already done. Stand on shoulders.
Exactly. Why reinvent the wheel? See how the experts break it down.
Okay, good starting point. What's the second question?
Second, what facts, concepts, and procedures must be acquired?
Breaking it down.
Yep, into its fundamental atoms. So, facts. Stuff you just need to memorize. Vocabulary, dates, formulas, concepts, the ideas you need to truly understand, principles, theories, explanations, and procedures, the steps you need to do, methods, techniques, workflows.
Okay, facts, concepts, procedures.
Thinking this way turns a big, scary learn Spanish goal into a concrete list of things. Memorize these verb conjugations, facts. Understand grammatical moods, concepts. Practice forming sentences, procedures.
Makes it feel much more manageable, less like this giant amorphous blob.
Totally. Gives you an actual to-do list.
All right. And the third question from Scott Young.
What fine-tuning and feedback are needed? Because let's face it, your first map won't be perfect.
Needs adjustment based on reality.
Right, so you need continuous adjustment. And he emphasizes 2 things running in parallel here. Drills.
Practicing the atoms.
Exactly. Flashcards for facts, practice problems for concepts, repeating a specific technique for procedures, mastering the building blocks.
Okay. And the other thing?
Direct practice. Using the skill in the real world, or as close as you can get.
Yeah.
Solving actual hard problems, having conversations in the language, writing real code for a project.
Testing the whole system, not just the parts.
Right. That's where you see if your map actually works, where the gaps are, and how to adjust it. It's that feedback loop that drives real learning.
Okay, that framework from Scott Young seems really practical. Build on others, break it down, practice the parts, practice the whole, adjust.
It's a solid approach. And speaking of practical frameworks, another big name in accelerated learning is Tim Ferriss. He has his own system.
Right, the DISS framework.
Yeah.
And CAFE.
Exactly. DIS plus CAFE. But before diving into the acronyms, he stresses this outlier mindset.
What's that about?
It's about challenging the idea that you should just copy the average or follow conventional wisdom. He says, often you should model the outliers.
The exception.
Yeah, those people who get amazing results despite maybe not having the right background or using standard methods. He mentions examples like Shinji Takeuchi learning to swim seriously at 37 for triathlons.
Okay.
Or strength coach Barry Ross getting incredible results with weightlifters using totally unconventional techniques. Ferriss argues the top 1% often succeed in spite of their training, not because of it.
So look at the weird successes, not just the standard path.
Right. Find the anomalies and figure out what they're doing differently that actually works. He also has this other kind of counterintuitive idea, material beats method.
Material beats method. What does that mean? Sounds backwards.
It does, right. But his point, especially for things like language learning, is that what you choose to study can sometimes matter more than how you study it initially.
Example.
He talks about learning Japanese grammar effectively by studying judo textbooks.
Judo textbooks. Why?
Because even though the vocabulary was specialized, judo terms, the grammar structures used were extremely high frequency in everyday Japanese. So he was drilling the most essential grammar constantly, just through that niche material.
So find the material that contains the highest concentration of the most important stuff you need to learn.
Exactly. Find the highest frequency material first. Optimize what you learn before you over-optimize how.
Interesting twist. Okay, let's get into his main framework. DISS. The first D is deconstruction.
Right, deconstruction. This is similar to Scott Young's breakdown, but maybe even more granular. Ferriss talks about finding the minimal learnable units, like Lego blocks.
The absolute smallest pieces you can practice and master.
Exactly. A single guitar chord, one specific chess opening, a basic conversational phrase. And a key tactic he uses here is interviewing experts.
How does he suggest finding them?
He says look up past champions, check Wikipedia for leaders in a field, Google for local experts, maybe even instructors at nearby schools or gyms.
Okay. And once you find someone, what do you ask them to deconstruct the skill?
He has some killer questions. Things like, what are the biggest mistakes beginners always make? What are the biggest wastes of time I should avoid?
Cutting straight to the chase.
Totally. Also, what are your core principles or mental models? What resources do you recommend? And his classic, if you had to train me in X weeks for $1 million bet, what would that training actually look like day by day?
Puts them on the spot to reveal the essentials.
Right. He talks about doing this with a basketball coach, Rick Torbett, and getting immediate shooting improvements just from understanding the key mistakes and principles.
Okay, so you deconstruct into Lego blocks using expert advice. Then the first S in DISS.
That's selection. Applying the 80-20 principle, which 20% of these Lego blocks will give me 80% or more of the results I want.
Focusing on the highest leverage points. Maximum efficiency.
Exactly. Don't try to learn everything at once. Pick the critical few.
Makes sense. Next S.
Sequencing. What's the best order to learn these selected blocks in?
Building a logical path.
Yeah. Does learning block A make block B easier? Should I master technique X before attempting Y? Designing the optimal learning flow.
Okay. And the final S.
Stakes. This one's about motivation, but with teeth. Setting up real consequences, positive or negative, to ensure you actually stick to the plan.
Skin in the game.
Big time. Ferriss talks about things like financial bets, public commitments, or even in his case, dropping out of college temporarily to force himself to learn languages. Make the cost of quitting higher than the pain of practicing.
That's intense, but I can see how it would work. So that's DISS, deconstruct, select, sequence, stakes. What about the CAFE part?
CAFE are secondary principles, kind of like boosters. C is for compression.
Compressor.
Can you boil down the most important 20%, those key blocks and sequences, onto a single page? A cheat sheet?
A quick reference guide?
Exactly. Distill the complexity into something easily digestible for quick review.
Okay. F.
Frequency. How often should you practice? And crucially, what's the minimum effective dose?
The MED.
Minimum effective dose, like a medicine. Sort of. What's the least amount of practice in terms of volume or duration that still gives you the desired result? Avoid burnout. Find the sweet spot for consistent progress.
Smart. Maximize results, minimize wasted effort. And E.
Encoding. How do you make the new stuff stick in your memory? Anchor it to what you already know.
Making it memorable.
Right. Using mnemonics, vivid mental images, analogies, even acronyms. Like DIS, SS, and CAFE themselves. They're encoded for easier recall.
Huh? Meta. Using the technique to remember the technique.
Yeah.
And this whole DIS plus CAFE system, Ferriss has used it for some pretty impressive feats, right?
Oh, yeah. He documents using it to get rapidly proficient in languages like Japanese, Mandarin, German, Spanish, famously winning the Chinese national kickboxing title with like less than 2 months of specific training.
Kickboxing, wow.
And significantly boosting his deadlift strength very quickly. It shows the framework's power across really diverse domains: language, sports, physical skills.
That's compelling evidence for these practical frameworks. Now, what's fascinating and kind of brings this full circle is that this whole concept, learning to learn, isn't just for us humans. It's a huge deal in artificial intelligence, too.
Absolutely. The same fundamental challenge exists for machines. How can they learn new things quickly and efficiently without needing massive data sets every single time?
Like how a child learns what a cat is after seeing just one or two.
Exactly. Or how we learn to ride a bike without millions of trial and error attempts. AI researchers are actively building models designed to learn, to adapt rapidly to new tasks.
So how does that work in AI terms? Is it like one AI teaching another?
You can kind of think of it like that. Often there's a base learner model that actually performs the task, like image recognition.
Okay.
And then there's a meta learner model that operates at a higher level. Its job isn't to recognize the images itself, but to learn how to update the learner model's parameters really efficiently, especially when only a few new examples are available.
So the meta learner learns the best way to teach the learner.
In essence, yes. It learns the learning process itself, enabling rapid adaptation.
Yeah.
It's trying to mimic our ability to generalize quickly from limited experience.
Are there different ways that AI field approaches this meta-learning problem?
Oh yes, it's a really active area. Broadly, there are 3 main categories. Metric-based approaches focus on learning a good way to measure similarity, so new things can be classified based on what they're close to in the learned space.
Okay.
Then there are model-based approaches, where the AI's architecture itself is designed for rapid learning, maybe using internal memory to recall past learning episodes.
Building fast adaptation into the structure.
Right. And finally, optimization-based methods focus on learning the optimization algorithm itself, essentially, figuring out the most efficient way to update the learner's parameters when faced with new, limited data.
Wow. So the core idea of learning how to learn is being tackled from multiple angles in humans and machines.
It really underscores how fundamental this concept is. It cuts across disciplines.
Okay, we have covered a lot of ground here. From the deep science validating self-regulated learning,
Showing it demonstrably works and sticks around.
to really practical frameworks from people like Scott Young and Tim Ferriss for mapping out and accelerating skill acquisition.
Breaking things down, focusing on the essentials, setting stakes.
And even seeing how the same learning to learn challenge is driving innovation at the cutting edge of AI.
The common thread is clear. Mastering the process of learning itself, meta-learning, is arguably the ultimate meta skill. It's your personal key to unlocking almost anything else.
So maybe here's a final thought to leave everyone with. We live in this world just saturated with information, data everywhere, but maybe starved for real wisdom, real understanding. What if the true advantage moving forward isn't just accumulating more knowledge, but developing your ability to learn quickly, effectively, and continuously? How might intentionally cultivating your own meta-learning skills, becoming a master map maker for your own learning, not just boost your performance today, but fundamentally change your capacity to adapt, innovate, and thrive in whatever the future throws at us?
It's something to think about. It's about building your capacity to evolve,